Today we're going to be starting activity 13. So we're starting with lesson 13-1, which is going to talk about angle relationships in triangles. So we're going to learn some theorems today about the angle measures in a triangle. So open up to page 181 in your Springboard book, and let's get going with some theorems here. So we're going to be applying some theorems about angle measures in triangles today. That's kind of our main point. Now, this whole activity is about this architectural design of the Rock and Roll Hall of Fame in Cleveland that includes triangles. So you're going to be hearing a lot about this kind of scenario with this guy, Jason, who owns a glass company and is cutting glass for the repairs of this triangular facade. Okay, but I'm just going to jump down here to the bottom where we talk about what the triangle sum theorem is. Now, in the questions 1, 2, and 3, it's kind of like an experiment to get you to come up with this theorem, but I think we already know what this is, that we know that if we have a triangle, okay, that the sum of those measures of the inside angles, so the sum of the measures of a triangle is going to add to 180 degrees. So if we add up all of our angles in a triangle, they sum to 180. So I think we already knew that, so that's why I'm skipping questions 1 through 3. But let's go to the next page here, where we have another vocab line, our vocab word. It's an auxiliary line. So when you're given a figure for a proof, you cannot change anything about the figure, but you can add a line to a figure to help you complete the proof. This line is called an auxiliary line, okay? So if we remember, now this is from Unit 1, that parallel postulate, that says that you can take a line, make a parallel line through any point P in any picture. So for example here, this is the proof for our triangle sum theorem, but what they're saying is I can take a line, an auxiliary line, and I can pass it through point A, and I'll draw this line AD. I didn't connect that very good. But like this. That's what an auxiliary line is. So you can draw in any line that you want into a picture to help you with a proof. Okay, so draw a line through point A that is parallel to BC. So those are two parallel lines. So the parallel postulate allows us to do this, but this proof is going to go through how we can prove that all the sums, angles 1, 2, and 3, how those add up to 180. So here is that proof. A lot of it is using parallel lines and knowing that things are supplementary and angle addition postulate. So you can go through this proof if you want, but honestly, what you need to know from it is that if we have 3 angles inside of a triangle, they add up to 180. So let's go through some more vocab here. So this is kind of the main focus of today's lesson, is these types of angles. So we have an interior angle of a triangle, and that is an angle that is formed by 2 sides of a triangle. Okay, interior means inside. An exterior angle of a triangle is formed when one side of the angle and an extension of the adjacent side. So if you see in this little kind of picture down here, we have our triangle. Just gonna try to highlight this. Okay, we have our triangle here, and then we have an extension of that triangle using that line here. That's what they're talking about when they say it's formed by one side of the triangle and an extension of the adjacent side. We have an extension of that line CB. Okay, so this angle 4, that's my exterior angle. It's outside the triangle. The last one is a remote interior angle, is an interior angle that is not adjacent to a given exterior angle. So that would mean like angle 1 and angle 2, those are remote interior angles. And angle 3 then is an interior angle. So technically 1, 2, and 3 are all interior angles, but since 1 and 2 do not connect to that exterior angle, we would call those remote interior angles. So this is just from your book, but it's the exact same thing I just said, okay? So those are your types of angles. Now, they all have a certain relationship together. So if we were in class, we would be doing these questions where we use a protractor and measure them. But the main point here is to get to this exterior angle theorem, also known as a triangle sum theorem. But if we have a triangle like the picture above here, where we have that exterior angle, the measure of the exterior angle is going to be equal to the sum of the measure of the non-adjacent angles. And so if this is in plain English, let me kind of translate that for you. the measure of the exterior angle, so in this case, angle 4, is the same thing as the sum of your remote interior angles. So angle 4 is the same thing if I added angle 1 plus angle 2. That's what this exterior angle theorem is telling us. So the exterior angle is congruent to the sum of the two remote interior angles. Okay, so there is a proof down here that goes along with this. Okay, so if we have this picture, how we can prove it, I'll show you what the proof is, and you can go through it. Okay, so we know from our triangle sum theorem, we can add angles 1, 2, and 3 together. Those are 180. Angles 3 and 4 are supplementary. So the rest of this is just kind of some substitution, okay? Kind of plugging things in to show that the measure of angle 4 is the same thing as the sum of measures 1 and 2. Okay, so let me kind of break this down for us again a little bit. So basically what this proof is saying, we know from our picture angle 3 and angle 4 are supplementary. So they sum to 180 degrees. And we also know that since angles 1, 2, and 3 form a triangle, angles 1 plus angle 2 plus angle 3 also equal 180 degrees because of our triangle sum theorem. So all that exterior angle theorem basically is doing is just kind of taking some substitution. It's substituting angles 1 and angle 2 for angle 4. So these are equivalent. Measure of angle 1 plus the measure of angle 2, the same thing as the angle 4. Okay. So just knowing that the exterior angle theorem is saying that angle 4 is the same thing as adding angles 1 and 2. Theirs will be equivalent. Okay. So let's actually try some problems where we use this theorem. Okay. So this example A here is going through, Jason knows that the section of the glass facade, the measure of angle 2 is 3 times the measure of angle 1, and you're finding the measurements for all 1, 2, and 3. So this goes through how to solve that, so you can look at this example on your own, but let's look at example, try this A. So it says the measure of angle 2 is 10x plus 2 degrees, and the measure of angle 1 is 11x minus 11 degrees. So we need to find the measure of angles 1, 2, and 3, all my interior angles here of my triangle. But we know from that exterior angle theorem that if I take the measure of angle 1 and add it to the measure of angle 2, it should be equal to that exterior angle. So let's kind of set it up here. We have the measure of angle 1 plus the measure of angle 2. That has to be equal to my exterior angle, which is 138 degrees. So let's substitute in here my equations. So angle 1 was 11x minus 11. And then if I add my angle 2, which was 10x plus 2, it should equal 138. So let's combine up like terms here. 11 plus 10 is 21x. Negative 11 plus 2 would be negative 9, equal to 138. So if we do all of our work here correct, we should get that x is equal to 7. Okay. So that means if x is 7, let's plug it in. So our measure of angle 1 was 11x minus 11. So 11 times 7 minus 11 should give us 66. Okay. Next, if I find angle 2, well, the measure of angle 2 was 10x plus 2. So let's see, 10 times 7 is 70, plus 2 would give me 72. So now just to find the measure of angle 3, I would just have to take 66, my two other angles, and subtract it from 180, right? So the measure of angle 3, I would take 180, subtract off my other two angles that I know, 66 and 72. So the measure of angle 3 should be 42 degrees. Okay? So again, using that exterior angle theorem to help me set up my equations, And then after that, it's kind of a domino effect in how you get that last value. Again, they all have to add to 180. So if I know two of them, just subtract it from the total and you'll get the rest. So I'm going to have you guys try two problems on your own here from the lesson practice. So below is a figure. So you're going to use that figure to find the measure of angle 1 and the measure of angle 2. So go ahead and try this problem right now on your own and come back for the answer here. So pause the video and try these two problems. Okay, so if you got the measure of angle 1, should have got that it was 35 degrees, and the measure of angle 2 was 55 degrees. Now, if you want to see my work, here it is. So measure of angle 2 and 125, those are supplementary. So I set those equal to 180. That gave me the measure of angle 2 of 55. And then I use that value for angle 2 to find angle 1 because angles 2 and 90 plus angle 1 have to give me 180. So that makes angle 1 35 degrees. So again, the big takeaway today is knowing those types of angle relationships, especially the exterior angle theorem.